Hello and welcome everyone. Thank you so much for joining us in this session today. My name is Anita and I'm a program manager on the Azure Machine Learning team here at Microsoft. And along with me today, we have Vijay Kannan and Lou Zhang here to join us. Now, before we begin, I would like to give you a quick overview of what's on the agenda today. So, as we all know, machine learning is everywhere and in every industry. It can be simple as figuring out the price of a car or trying to figure out how much food to keep in hand in a restaurant so that customers are satisfied and to make sure that we reduce waste. Now, the only issue here is not everybody can become a PhD in statistics and data science, and there has to be an easier way to fast track the ML process so it will be accessible to anyone. And that's exactly what we're going to be talking about today. Today, we will be covering 3 topics: data labeling, designer, and automated ML, and see how you could fast track the ML process with Azure Machine Learning. And before we begin, I'm going to pass it over to Vijay.
Thanks, Anita, for the intro. Talking about data labeling, this is an important step in training a machine learning model. We need to have good quality images in order for the model train to be accurate. At a high level, this is how the data labeling flow works. We have unlabeled data. Then there is a task creator component which takes this unlabeled data set and starts generating tasks for the human labelers. The human labeler picks these unlabeled tasks and starts generating labeled data set. And this process continues and it goes on and on. At this point, you are free to export the data if you want. However, we do something more interesting here. We train a machine learning model behind the scenes, and then this will generate outputs. And we will use the output of the model in several ways. First, we will try to use the output of the model to cluster the data points together. And once these clustered data points are controlled, these clustered data points are served to the human labelers. They will start seeing similar objects coming together as part of clustering. And this will primarily reduce the cognitive load or context switching for the human labelers while doing the labeling, which will primarily help on the labeling speed. Next, once the accuracy of the model exceeds beyond the confidence threshold, the machine learning process will start generating pre-labels. And these pre-labels are viewed by the human labelers. They can have the option to modify those pre-labels, or if it looks accurate, they can just go ahead and keep submitting those labels. Again, the pre-labeling concept primarily helps in speeding up the labeling process. Now, let's talk about a user scenario. I'm Sarah, a data scientist working in an open image sourcing company. My company is primarily focused on collecting thousands of images through a crowdsourcing way, and it wants to classify those images into various categories. I'm not a fan of coding, and I don't want to use any of the coding tools, which I want to go and do all the coding. So I prefer the option of drag and drop. So that's fair. And I want to spend most of my time as part of a data scientist role. So first, what I want to do is I want to use the Azure ML data labeling tool and take all the labeled images, right? And then I want to train those images into the Azure ML Studio Designer, and then in training the machine learning models. In my project, I want to classify those images into various categories like warehouse, bookstore, and as well as a subway. In today's walkthrough, we will cover using a data set which is available in the Azure Blob Storage. Then we will create a data labeling project. After creating a data labeling project, we will go ahead and label data ourselves. We will continue labeling few more images. Then we will log back into the project and check the quality of the labels, how it looks. At this point, we'll also look at how to export the data as an AML data set. We will also look at how to take this AML labeled data set into Designer Studio and train a machine learning model. We will also look at how to take this and deploy it as a real endpoint. Next, we will get to the very interesting portion, the demo of AML data labeling tool. For this demo, I'm a data scientist who wants to spin up a data labeling project and get the images labeled for my model training. As part of this project, I have close to 600 unlabeled images of bookstore, warehouse, subway stations. And these images are in my Azure Blob Storage location. Before I jump into creating a data labeling project, I need to prepare the data. As part of it, I need to do two fundamental things. One, create the data store, which is like establishing a connection string or pointed to the Azure Blob Storage location and containers. And number two, create the data set, which will point to the exact folder in the container where images are stored. Once these are set up, now we are ready to create the data labeling project. I will click on the data labeling assert under the manage section. Here, you will see the list of projects which is in progress, state, who created, and when it was created. Now I will go ahead and click on add project. Creation of project involves few steps. I will provide the project name. I will choose the project type as image classification multi-class. With this, you'll be able to assign only one label per image. The other type which are supported are image classification multi-label. With this, you'll be able to assign multiple labels to the same image. And the next one is object detection, which is drawing rectangular bounding boxes in the images. I'll click next. Here, I will choose the data set as MIT indoor 3. Next is about enabling incremental refresh. I will enable this incremental refresh if I'm going to continuously receive new images in my Azure Blob Storage location and continue labeling those images as it lands. Enabling this will set up a daily polling process, which will help in fetching those new images. Next step is defining the label. In this case, I'm going to provide three labels as warehouse, subway, and bookstore. In this page, I can provide a set of instructions or guidelines which my labelers can follow during their labeling process. The last step is enable ML assisted labeling. I can choose this option if I want to seek the help of the machine to do automated pre-labeling after labeling few hundred images manually. In this scenario, the machine will pre-label. I just need to verify and submit it. Here, I also need to provide a GPU compute. Now I will go ahead and click Create Project. The project creation process takes few minutes based on the number of images. Now the project has created successfully. I will click on the project. In order to label the data, I click the Label Data button. The first image shows up. Now I will go ahead and choose the corresponding label. So this is a subway station. I choose the label as subway and I click sum. Now the second image shows up. Here I will be able to adjust the zoom of the image, adjust the brightness, contrast, or even skip the images if it does not belong to any of these label classes. So this is a warehouse. I will choose the label as warehouse and submit it. This is how the labeling flow works. So now I will go back into the project by clicking on this link. Here you will be able to view the progress of the project by looking at the donut chart. You will also be able to view the label class distribution and also the progress made by the labelers. Also, if MLSS process was kicked in, you'll be able to see the status of the MLSS process as well. I have another image classification project which has reached the MLSS pre-labeling state. I will quickly show you how pre-labeling process works here. I am navigating to the project list, choosing the corresponding project, and then click Label Data. Now the first image loads up. I see already the labels have been marked by the machine. I don't need to do anything if everything looks good. I'm very happy how the tags are being assigned. This is a kitchen. So I will go ahead and click Submit. The next image shows up. Here, already the machine has marked the label as kitchen. I'm happy with this as well. I will go ahead and click Submit. Now, getting back into the project, you will see the MLSS experiment runs. If you are interested to know more about each experiment runs, click on the training experiment link, which will take to the experiment section. Here, you will see the list of all the experiments of the project. You will be able to see the metrics like precision and accuracy. Clicking one of the training runs shows up the details about the run, metrics, and the output logs. The metrics tab shows the list of metrics. You can choose the metrics which is of interest to you to analyze further. On the output logs tab, you will see the corresponding MLSS models which are used for model training and inferencing, which is primarily the pickle file. Here you have the option to download this model pickle file and use it in your mainstream training or inferencing. Now let's get back to our main project, bookstore, subway, and warehouse, to export the labeled data. So now I will go ahead and click export. Now the labeled data is exported. I can click on this link to view the labeled dataset. Now I will hand it over to my colleague Lu Zhang, who will provide a walkthrough of how to take this labeled dataset into the designer pipeline.
Thank you, Vijay. Now I got the labeled dataset registered in my workspace. I can easily check from the Datasets tab from the Azure Machine Learning Studio on the details. I can also click on Explore tab to preview the images as well as the labels. I'm going to use the drag and drop UI Azure Machine Learning Designer to quickly build, test, and deploy a production-ready model. From the homepage of Designer, I can see there are already a bunch of examples available for me to choose from. There are image classification, recommendation, linear regression, as well as customized Python and R code to train my own model. I find the first example, image classification using DenseNet, is very close to the project I'm working on, so I just opened it. By looking at the pipeline, I find it takes the animal image dataset as the sample and convert it to image directory, then split using a ratio to training and test dataset. It then does a bunch of image transformation and takes DenseNet as the input to train a PyTorch model. I'm going to replace the sample dataset with the bookstore, subway, and warehouse data, which is registered in my workspace. I can easily find it from the asset library, and I can also drag and drop a custom module that can convert the labeling dataset into an image directory. I'm going to submit this pipeline to a GPU cluster that can accelerate the training. And I will use an existing experiment to kick off the pipeline run. Now the pipeline starts running, and after several minutes, I should be able to track the run results from here. I can right-click to visualize the scored dataset. Each row here represents an image, and the columns are the probabilities assigned to each class. The score label is actually telling me which is the category being assigned to this image. And I can evaluate the model by right-click to visualize the overall accuracy, precision, and recall number. If I'm not satisfied with the training result, I can go back to see the train PyTorch model and change the parameters here on the right panel to retrigger a pipeline run. Now I will move forward to create an inference pipeline for deployment. I can click on the button, and the system will automatically generate a real-time inference pipeline. By looking at the pipeline, it takes the web service as the input, apply the image transformation as I did in the training pipeline, and takes the trained model and score the actual input for the prediction. It will return as the web service output, and I can easily click on the deploy button, choose an Azure Kubernetes cluster for deployment. It will kick off the deployment, and after several minutes, I can easily check the deployed endpoints from the endpoints page in the studio. By looking at the details, I can check the current status, who created, and the rest endpoints that you can easily copy-paste. I want to verify how good the model is performing. I can easily go to the Test tab and select an image from my desktop. And I can click on the test button to see the actual prediction in a few seconds. As you can see, this model predicts pretty well on the image I select. Now I will move forward to do the actual integration with my application. I can get the basic consumption information with the tokens and the REST endpoint. I can also get the consumption code, which is written in C#, Python, and R, that I can easily integrate with my application. This is very handy for my actual deployment and production integration. So with the Azure Machine Learning Designer, I can easily connect and prepare data with all these built-in modules. I can build and train models without writing any single line of code. I can validate and evaluate model performance with all this visualization. And I can deploy models and publish endpoints with just a few clicks. Next, I'm going to hand over to Anita, who will show how to use automated machine learning to do forecasting.
Well, thank you, Lou. As a developer new to machine learning, I want to simplify and streamline the model creation process because building models can be tedious and iterative. You start off by choosing features, choosing your algorithm, tuning your hyperparameters, and then iterating on your data as many times until you find that optimized model. And as you can see, this is a time-consuming process, and there has to be an easier way to do this. And that's exactly where automated ML comes in. With AutoML, the user will only need to bring in their data set, identify the task type, is it a classification, regression, or time series forecasting task, and then maybe set some constraints. Maybe you just want to run it for 3 hours, or maybe end the experiment when it reaches a specific metric value. And then what AutoML does is it intelligently tests multiple models in parallel and returns the optimized model for you. Now, let's take a look at this user scenario. I want to introduce you guys to John, who is a data engineer, and his goal is to forecast energy demand. And this is important for his company, which is in the energy sector, as it needs to maintain a fine balance between the energy consumed on a grid with the energy supplied. Now, as you can tell, John understands his data very well, and he knows the business needs. He has a basic understanding of what ML can do for him. And John does not have the time to create experiment and tune hyperparameters. He just wants to get started quickly. So let's see how John can use automated ML from the Azure Machine Learning Studio to forecast energy demand. We are now back in the Azure Machine Learning Studio where John will use automated ML to forecast energy demand. So when John clicks on automated ML, he will see all of his previous runs charted out over here. But for this example, we're going to go ahead and click on new automated ML run. So the first thing that John will need to do is select a data set. And John has a couple options here. He could either upload it from local files, from data store, from web files, or open dataset. But for this example, let's go ahead and use this NYC energy data that was already uploaded. Now, the next thing that John will need to do is configure his run. So before we do that, let's go ahead and view the data set and let's make sure John is comfortable with it. So we can see this is how the data looks like, and in this case, demand is the feature that we're going to be predicting on. Now, John can get additional details about his data by clicking on data statistics. And now this will help him better understand his data and know it inside out. Now, once John has a good idea of his data, he can go ahead and give his experiment a name, and in this case, we'll just call it NYC Energy, and then choose the target column. So this is the column we're going to be predicting on. In this case, it's demand. The next thing John will need to do is choose a compute cluster, and what's great about AutoML is that the compute will automatically scale to the experiment needs. So now that we have our compute cluster selected, let's go ahead and choose the task type. AutoML currently supports classification, regression, and time series forecasting task types. So we know in this example, it is a time series forecasting. So let's go ahead and select that. And then the next thing that John will need to do is choose the time column. So in this case, it's timestamp. So AutoML has some additional configuration settings. So for example, if you click on View Additional Configuration Settings, you could choose your primary metric, you could block some algorithms, and just customize your run based on your experiment needs. I'm going to go ahead and run this just the way it is. So I'm going to go ahead and click Finish. And now what's happening is AutoML is intelligently testing multiple models in parallel, and it's going to return the optimized model for us. So as we can see, this run has just kicked off. So I'm going to go back to experiments over here and open up an old run so that we could see the progress and see how it looks like. So I'm going to go ahead and click on this completed run over here. And what we see here is the best model summary. So this is the recommended model, which is Stack Ensemble. We see the metric, normalized root mean squared error, scored of 0.01739. And if we're not satisfied with that, we could go ahead and click on View All Other Metrics and look at that to provide us a better summary of this run. Now, what's great about AutoML is it's not only testing one model for you, it's going to test multiple. So you can see that within this one experiment, we see there's a stack ensemble, voting ensemble, robust scalar, gradient boosting. So we don't really need to go with the recommended model. If John prefers to choose this voting ensemble, he could go ahead and click on that and explore it. So let's do just that. So let's click on this. And so what we can see here, we see the additional metrics as I showed you earlier. If I click on this metrics tab over here, it provides me with additional visualizations to better understand this model. So we see this predicted versus true, and by looking at this, we could see that it's pretty much what we're expecting. And once we are satisfied with this model, we could go ahead and deploy it. So I'm going to go ahead and click deploy. So what this does, it opens up a panel where John will need to first start off by providing his deployment a name. And in this case, let's go ahead and call this NYC Energy. Next, John will need to decide the compute type that he wants to deploy to, and he has a couple options over here. He could either deploy to Azure Kubernetes Service, which is usually a production environment, or Azure Container Instance, which is a testing environment. So let's go ahead and use Azure Container Instance. And what John will need to do now is just go ahead and click deploy, and what's happening is it's going to automatically register the model for John. So he could go ahead, click on models over here, and he could see his registered model, NYC Energy. And if he goes to the endpoints tab, he could see the deployed model. So in this case, we could see the energy demand model right here, NYC Energy. And this one is still in progress, but once it's ready, you'll be able to go ahead and consume it. So that's the power of using automated ML to forecast energy demand for someone working on a scenario similar to John. We are now heading to the Q&A part of the session. Remember to keep your questions coming in the chat. Now, the first question goes over to Vijay. You were talking about labeling earlier, so how does ML-assisted labeling work?
Thanks, Anita, for asking this question. Once certain number of data points are manually labeled, the data labeling service automatically trains a machine learning model in the background periodically. It also validates the model and calculates the pre-labeling threshold for every class. When the number of available tasks falls below the queue limit, say in this case it's 300, the data labeling service will use a trained model to generate the prediction for the next bunch of data points. Based on the confidence value with the threshold, the images are split into two categories. For the images with the confidence value greater than the threshold, the task producer will create tasks with pre-labels assigned. The human labelers just need to review those pre-labels, and if it looks good, they keep submitting those images, or if it needs a modification, they can go and make edits to those labels. And this primarily helps on accelerating the labeling speed for the human labelers. For the images with the confidence level lower than the threshold, the task producer cluster the images more like a grouping of images. Here, the labelers will start seeing images being grouped together. Providing similar images to human labeler reduces the context switching or starts facilitating a higher throughput for the labeler. Now, I have a question to Lou. Lou, in addition to data DenseNet, what other algorithms do you support in Designer?
Thanks, Vijay, for asking this question. Designer has modules covering different domains, including these commonly used machine learning algorithms, computer vision, text analytics, recommendation, anomaly detection, etc. You can also bring in your own code into execute Python or R script module for your data processing, module training, and evaluation. We have the plan to launch a new custom module experience, which will make your code sharing and reuse much easier within the workspace. This will also bridge the UI and code experience, since it will be very easy to export the pipelines generated from the UI to the Python files or notebooks that can enable a better collaboration between these no-code, low-code data scientists and code-first data scientists in a team. So Annie, my question to automated ML is, what are the upcoming features on the roadmap?
Great question, Lou. Well, first of all, we recently released our many model solution accelerator. So we've heard from customers where you want to build multiple models in parallel, let it be tens, thousands, or even hundreds. So now you can build that using our solution accelerator. Another item that is coming on our roadmap is hierarchical time series. So this is building on top of our many model solution accelerator. And with that comes additional forecasting enhancements. And finally, another exciting feature that I'd like to talk about today is CodeGen, allowing users to run an AutoML UI experiment and being able to generate code out of that. Now, that brings us to the end of our Q&A portion of the session. Thank you so much for joining us in this session today. Now that you have all the puzzle pieces, let it be designer, labeling, or automated ML, we would like you to get started. So you can try it for free by visiting ml.azure.com. You can learn more by visiting our docs, and we also have some sample notebooks for you to get started. Now remember, if you run into any questions, let it be for labeling, designer, or automated ML, feel free to reach out to us at these emails provided. Thank you.